Okay, so our second, slightly more accurate, slightly more precise version of determining oxygen is our iron wall experiment, our second one down here. This one takes a long time, so we're not going to see the results of it today. You'll actually collect the results of this one when you're back in school next week, because it needs 5, 6, 7 days for it to be completely reacted to ensure that it definitely works. But we can have a look at the start of it. So in this case, you would have a boiling tube, a beaker of water, and the bottom of the boiling tube is in the water, okay? And in the top here, we have iron wool, okay? And as we know from our topic earlier, our reactivity topic, reactivity and extraction, iron will rust in the presence of oxygen and water to form iron oxide. So the idea here is that you leave the iron there long enough that all of the oxygen that is trapped in the tube, because obviously it's sealed with water at the bottom, will react with the iron to form the rust, form the iron oxide. And like with our candle, the vacuum created by the oxygen being used up and turned into a solid will pull the water up, and we can measure the change in the water level. Now again, it's not brilliant because we haven't got any measurement scale on the boiling tube. You could use a measuring cylinder to get more of a measuring scale on there if you wanted to, but it ruins the bottom. The rusting doesn't come out, so we tend to use a boiling tube, but you could use a measuring cylinder to improve it so that you could actually use the measurement scale. And obviously this is very slow. However, it is definitely more accurate than our burning candle one. You are creating a solid, the iron oxide, instead of a gas, the carbon dioxide. So the boiling tube is not being filled up with another gas. So you are definitely pulling the gas out of the system. So the volume change will be more accurate, definitely. And you will also much more likely to have used up all the oxygen because you're leaving it for several days. There is far more iron in this. The iron is not going to be the limiting agent in here. It's not going to stop reacting. You're going to run out of oxygen first. So you are likely to have used up all the oxygen. If you wanted to check with this one that you've used up all the oxygen, you just leave it for another week. And if the water level hasn't changed, you know all the oxygen was gone in the first place because the oxygen will keep getting used up by the iron. So this one is definitely more accurate. So at the moment we have our boiling tube. The best way to check our volume of our boiling tube is to get a measuring cylinder, fill the boiling tube up, measure the volume of the boiling tube. So we have our boiling tube full of water. We have a measuring cylinder that you should be able to see. So we can measure our volume of our boiling tube by finding out how much water is in there. It's a bit over 50. I need a 100 ml one. 100 ml one right there. Usually around the 50 ml mark. So let's pour it in. So our starting volume is 55. Okay, so our initial volume of air will be 55 centimeters cubed. And then next week, when you look at it, you will be able to work out how far up the boiling tube the water has moved. And then using a similar method, fill up the same amount of water in here, put it in the measuring cylinder, you know how much air has been used up. Hopefully that one will work for us next week.